All right. When I looked at this first one, at first I was trying to apply what I knew about limits. And so I was thinking, like, can I simplify anything there? And when I was looking at it, kind of got confused. The answer choices seemed really weird to me. So what I decided to do was at least try direct substitution to see if that would give me an idea of this limit. So I went ahead and I plugged in 1, and that gave me ln of 1 plus 1 minus ln 2 over 1 minus 1. So immediately this 1 minus 1 was like, that's not good, that's 0, so I'm going to have to do something. But then I looked at the top and I was like, oh, that's ln 2 minus ln 2, which is 0 over 0. And if you guys recall, anytime we have 0 over 0, I think the other one is infinity over infinity. This one just seemed to be more common. I meant we had to do L'Hopital's rule. I was like, perfect. I remember how to do that. So L'Hopital's just says take the derivative of the top and take the derivative of the bottom and write them out, and then do direct substitution again and keep doing it until you don't have 0 over 0 anymore. So the derivative of ln is 1 over the inside times the derivative of the inside, so the derivative of x is 1, minus ln 2 is just a number, and the derivative of a number is 0. And then on the bottom, the derivative of x minus 1 is just 1. So that simplifies to be 1 over x plus 1. And again, I can do direct substitution there. And if I plug 1 in for x, that gives me 1/2. So once I got that, that helped me get rid of some of my answers here. So I know that the limit exists. I know that the limit is not 1, it's not 0. So that kind of narrowed it down to these two. So b d dx, parentheses around ln x plus 1, means the derivative of this. So the derivative of ln x plus 1 is 1 over x plus 1 times 1. And that's part of the answer, but that doesn't include the part where we plug 1 in and evaluate it. So this other one says f prime of 1, which means the derivative evaluated at 1, if the function is ln of x plus 1. So if the function is ln of x plus 1, then that derivative is this, and then it's saying the derivative evaluated at 1, which is the answer that we got. So C is the answer. So remember, that was one of the strategies I was kind of talking about, is if the answer choices are confusing, if they don't shed any light on the problem, ignore them and do what you can with the problem, because once you have a solution that you've done, you might be able to go back and make some sense of those answers and actually be able to use them. All right, problem number 2. I'm ashamed to say this is one of the ones I got wrong when I checked my own answers, and it was a silly mistake, so make sure that even if the problem is easy, you take your time and think about it. So this derivative, you can use the quotient rule if you'd like. I rewrote the problem as 4x to the negative third so that I would not have to do the quotient rule. And then we just remember we take the exponent, we multiply it by the front, negative 12x, and we drop the exponent by 1, and this is where I made my mistake. I was thinking of dropping it by 1 as giving me negative 2. It actually gives you negative 4 when you drop it by 1. And then you can rewrite that as negative 12 over x to the 4th. So just be careful to watch out for stuff like that. That was one that caught me too, because you'll notice negative 12 over x squared is an answer as well. So that was a common error, and that got me. All right, find dy dx. So here we've got some implicit differentiation. So we've got 3xy, and if you guys remember how to do this, x and y are being multiplied. That's actually the product rule. So I've got first times the derivative of the second. The derivative of y is 1 dy dx, plus the second times the derivative of the first, which would be 3. Equals the derivative of 4x is 4, the derivative of 2y is, of y squared is 2y dy dx. And then our next goal is to get the dy dx's to one side so that we can isolate them. So what I did next is I left the 3x dy dx on the left side, and I subtracted the 2y dy dx over to the left side. And then on the right side, I left the 4, and I subtracted the 3y over to the right side. So now I can factor out that dy dx. And that gives me 3x minus 2y. And then I went ahead and I took that whole parenthesis and just divided it over. So that gives me dy dx equals 4 minus 3y divided by, I don't need parentheses anymore. Oop, I'm off screen, sorry. 4 minus 3y equals 3x, sorry, divided by 3x minus 2y. Goodness gracious. Okay, so now I need to compare that with my answer choices and see which one makes sense. So here I can see them, there's some clear answers I can get rid of that had some things simplifying. I know that I cannot simplify this because I don't have a GCF I can factor out and have things cancel. So I know that these answers that appear to have been simplified are actually just wrong. I know that there's subtraction signs in the problem, so it's definitely not E. So now I have to figure out which one, A or B, that it is. The trouble with these problems is that I could have moved the dy dx to either side. So I know what should be in the numerator and what should be in the denominator, but my signs could be a little bit off depending on how you did the problem. So if I look at this, I can see this one, the top matches, but the bottom does not. So I know it's not A. So to me, it looks like it must be D. I do want to confirm that it's D. I just want to make sure I didn't make a silly mistake somewhere. So they have the order backwards from what I had. So I'm going to go ahead and rewrite this. I'm going to say negative 3y plus 4. And then I'm going to say negative 2y plus 3x. And then I still want it to look like this. I just want to make sure I did it right. I'm going to go ahead and factor out a GCF of negative 1. And that gives me positive 3y and negative 4. Do the same thing again. That gives me positive 2y and negative 3x. And then I can see those negative ones cancel. And so that is exactly the same as D. Now, if you're running out of time, I wouldn't do all of that. If you're running out of time, I'd say that's my best guess and move on. But if you're not running out of time, it's not a bad idea to just confirm that you got the right answer to make sure you didn't make some sort of mistake somewhere, like with the signs or whatever. Right. For number 4, when I did this one, I did not use the chain rule. You would have a little bit of a chain rule if you did the derivative of e to the x plus y like that, or you'd have to do the derivative of e to the x is e to the x plus y times the derivative of the exponent. What I did is I just felt a little bit more comfortable rewriting the problem as e to the x times e to the y, like that. And I switched the order. For some reason, I just didn't enjoy it written like that. So you could certainly try doing it with the chain rule and just see what ended up happening. I didn't feel like doing that. So here I set it up. So the derivative of y is dy dx. And then this made it so I was doing a product rule. So I did the first times the derivative of the second. So the derivative of the second one is just e to the y times dy dx. Plus the second times the derivative of the first. And the derivative of e to the x is still just e to the x. And then I went ahead and I just rewrote these. So I have dy dx equals e to the x plus y times dy dx plus e to the x plus y. And then I did the same thing as the previous problem, and I just got the dy dx as all to one side. So, and if you want to think of this as 1 dy dx, that might be helpful. So I've got 1 dy dx minus e to the x plus y dy dx equals e to the x plus y. And then I can go ahead and factor out the dy dx because it's in both terms. So I've got 1 minus e to the x plus y. And then I went ahead and took that set of parentheses and just divided it over. And so the answer, it actually matches up perfectly with A. This one felt a little confusing to me when I looked at the answer choices, so immediately I ignored them. So it says if the nth derivative is denoted as y to the n, and y equals negative sine x, then y to the 7 is the same as, and I ignored that. I was very confused by that, so I decided to just start writing. So I said, all right, if y is negative sine x, then the first derivative is negative cos, and the second derivative is positive sine, and the third derivative is positive cos, and the fourth derivative is negative sine, and the fifth derivative is negative cos, and the sixth derivative is positive sine, and the seventh derivative is cos. I am the type of person to show all my work and be really thorough, especially on a test like this. So if you kind of figured out the pattern and didn't write out all your work like that, that's not a big deal. But what I noticed after I showed all my work and was really thorough is that the third derivative and the seventh derivative are the same. And that's, once I wrote that, that's once I was like, oh, I understand what this problem was asking. So the seventh derivative is the same as the third derivative, and then I looked at the answer choices to see which one looked like a third derivative, and that was this one right here. So if you guys remember, y is the original, dy dx is the first derivative, d2y dx squared is the third derivative, or the second derivative, sorry, this is the third derivative. So it's just, they're basically asking if you understand notation. All right, problem 6. Sorry, I did a bad job of scanning the pages for this one, so there we go, problem 6. All right, the second derivative of this is just a chain rule problem to make sure that you're being careful about taking your derivatives. So my first derivative, I'm going to drop the 4 to the front. So 4 times 2x plus 3 to the third power, and then I have to multiply by the derivative of the inside, which is just 2. So that gives me 8 times 2x plus 3 to the third. And then I'll go ahead and find my second derivative. So 3 times 8 is 24 times 2x plus 3 to the second. And then I'm going to multiply by the derivative of the inside, which is 2. And so that gives me 48 times 2x plus 3 to the second. And that matches up with E. All right, at this point we switch over to being able to use calculators, so if that's going to be helpful to you, you can do that. Number 7 is another chain rule problem, and for this problem it's a sine squared, and I know we've talked about this before, but I chose to rewrite the problem. I know that the sine is being squared, the 4 is not, so I've got 4, and then I did sine of 3x squared. I wrote it like that so that I could think through how the chain rule should be working. So with the chain rule we do the derivative of the outside first. So 2 times 4 is 8, and we leave the inside the exact same. And then we do multiplied by the derivative of the inside. So the inside of this is cos. Derivative of sine is cos, so cos of 3x. So this, and now if I'm ignoring this, the sine is kind of like the outside function. So the derivative of the outside function is cos. I left the inside the same. Now I'm going to go ahead and do the derivative of this inside, which is 3. So 3 times 8 is 24. And then I've got sine 3x, cos 3x. And I can see that matches up with E again. All right. This problem took me some time. Once I saw that we were looking at different rates of things, I was like, oh, we're talking about a related rates problem, which was my phobia in calculus, and I carried that on into teaching calculus a little bit. So for me, this one, I had to really be careful when I did this problem. So when you look at these related rates problems, it's really important for you to identify what the big picture formula is, because there's usually some sort of formula involved that you have to then work with. So it might be, if it's a triangle problem, it might be the area of a triangle. If it's a cylinder problem, it might be a volume of a cylinder. If it's a cone problem, it might be the volume of a cone. If it's a puddle problem, it's going to be the area of a circle. All sorts of different formulas that you're going to have to kind of reach back to earlier math classes to remember what those formulas are. And then once you know what that formula is, then you have to think about what information they gave you, what number is a constant number that always stays the same, and what number is a derivative, what number is a rate of change for that problem. So when I looked at this, I was trying to figure out what the formula is. And right down here you can see what formula you should be using. It says, what is the rate of change in the area of the triangle? So that told me the big picture perspective I should have here is that I'm looking at the area of a triangle. So I said area is 1/2 base times height. Now the other thing I changed about this problem is I did not like labeling the sides as AC and BC and AB. I did not like using 2 variables for each side, and since this is a multiple choice problem and it doesn't really matter if I change the notation, I went ahead and called this X and called this Y and called that Z, because that made me feel a little bit more comfortable in doing the problem. So I knew that AC at some moment in time this value is 15, and at some moment in time this value is 20. So those are some specific numbers that we have. And then in the problem it said point A is moving along the leg of the right triangle towards C. So for me that was my X value at a rate of 1.2 centimeters per second, and I knew that it was moving in a direction that would make that side smaller. So because of that, I wrote over here that dx dt is -1/2 centimeters per second. And then it said that B is moving towards C at a rate of 1/3 centimeters per second. And so for me, that was my dy dt. And they're asking us to find the area. So dA dt is what we want to know. So I went ahead and rewrote my area formula so it was in terms of the variables that I had. So my base is y, my height is x. So dA dt is a derivative. So I went ahead and I said the derivative of a is dA dt. And then I noticed that this is a product rule. So I said 1/2 y. So the first times the derivative of the second, plus the second times the derivative of the first. And then I went ahead and I just plugged my numbers in. So dA dt is what I'm solving for. And then I have 1/2 times y times 1 plus x times 1/2 times I missed something up here. First times the derivative of the second. Oh, that should be a dx dt. I'm missing something. Sorry. When you guys are doing the related rates problems, make sure that every time you take a derivative of any variable, you always have a dx dt after a dy dt. So first times the derivative of the second, that would be 1 dx dt, plus the second times the derivative of the first, so 1/2 dy dt. So this 1/2 right here should actually be, with that 1 right there, should be a -1/2. Okay. Plus 15 times 1/2 times -1/3. All right, so 1/2 of 20 is 10. 10 times -1/2 is -5. I'm going to ignore the 1/2 for a second. -1/3 of 5 is or 15, sorry. -1/3 of 15 is -5. And then 1/2 of -5 is -2.5. Again, this is calculator active. You could just plug it straight in. So -7.5 is my number. I don't really have to worry about what my units were because they made the units the same in every single answer, so I know that my answer is D. All right. So here, number 9 says to find the derivative in terms of x and y. So ln y equals ln x squared plus 2. One thing to note, this ln x squared, I've seen people write it as ln squared x, kind of like sine squared x and cos squared x, so just watch out for that. I don't know if they'll use that notation, but I have seen it before. So just be aware that that's the same thing as this right here. Okay, so we're going to take the derivative. The derivative of ln y is 1 over y dy dx. And then the derivative of this, we're going to drop the 2 to the front, so that's 2 ln x to the 1 times, so I did the derivative of the outside. The derivative of the inside is 1 over x, and then plus 0. So I've got 1 over y dy dx. These answer choices to me, I looked at the answer choices to see like what form I should be leaving my answer in, and I saw that the 2 over x, they kind of kept together, so I just went ahead and wrote 2 over x ln x, because I could see that was kind of similar to what I was noticing here. And then we can go ahead and just multiply this y to the other side to get dy dx alone. And so I said 2 over x ln x, and I'm multiplying that by y. And then when I compared with my answer choices, I knew it wasn't any of these. I had to have a y in it because they said in terms of x and y. And then when I looked, it matched up with B. All right. I'm going to explain the shortcut to this problem, and then I'm going to show you all the work I did because I did not use a shortcut here. If g is defined as the inverse of f, plugging a 2 into f and giving you -3 means they're giving you a point. So if g is the inverse of that, that means that if you plug in -3, you're going to get 2. If your derivative evaluated at 2 gives you a change in y of 3 and a change in x of 4, because that's what slope means. So 3 over 4, then the derivative of g of x evaluated at -3 is going to give you the flipped version of that. So change in y divided by change in x, they would just be, those would have switched as well. So the easiest way to do this problem would be to say y minus 2 equals 4/3 x plus 3. I did not do it that way. I hardcoded this problem by hand. So for me first, I did recognize that this right here, 2 -3, was the point that they were giving me. I recognized that the derivative evaluated at a specific value is giving me the slope at that point. So what I started off with is I wrote, this is the shortcut, I wrote y plus 3 equals 3/4 times x minus 2. And then I got ready to do my inverse by hand. So I distributed my 3/4. 6 divided by 1, that's 3 over 2. And then I subtracted the 3 over. And again, you can be using your calculator here. You do not have to do these by hand. These calculations by hand. So once I had that, I went ahead and decided to go through the process of finding the inverse. And so I wrote x equals 3/4 y minus 9 over 2. And I added the 9 over 2 to the other side. So I got x plus 9 over 2 equals 3/4 y. And then to get rid of the fraction over here, I multiplied both sides by 4/3. So that gave me 4/3 x plus 36 over 6, which is 6 equals y. So that was me finding g of x. Now I know that this is what g of x equals. And then I said, okay, I need to find g of x I need g prime of x because I'm looking at the tangent line, so I need the derivative. So I said my g prime of x was 4/3. And I was like, okay, well that tells me that no matter where I'm at on the curve that the slope is always 4/3. And then I was like, okay, let me take my g of x and plug in -3. And when I did that, I got -4 plus 6, which is 2. So that confirmed all that information. But from that, I was able to say that I should have y minus 2 equals 4/3 times x plus 3. And then I thought, oh, silly, I should have noticed that. But either way, I was able to do the problem. So if you are able to think through it enough to do it this way, then that's great. But if not, you can still think about what you know about how to find derivatives and think about what you know about how to find tangent lines, and you could still do it by hand. So keep that in mind when you're approaching these problems, is if you don't have a definite way of getting to the answer, just start with what you know. So I knew how to find an inverse, so I did that. And then I knew how to find a tangent line, so I did that. Okay, so just think it through. All right, on this problem, I spent a ton of time trying to figure out what this problem was saying, using decimal answers to try to figure things out. I did a lot on this problem and I got it wrong. But I will say that I did spend so much time on this problem that when I finally looked back at how to get the answer, I don't think I will forget this strategy in the future, because it struck me like, that totally makes sense. So I would say that's actually a good learning experience to have, is that if you struggle a ton with a problem, give yourself, gosh, I probably worked on this one problem for 20 minutes, which for me as a math teacher, normally I just go straight to a problem and I'm fine. So I spent so much time on this problem. I think that that's a valid learning experience you guys should think about, is don't just take these and struggle for 3 seconds and then look at the answer. Give yourself a long time struggling with it, because then when you go back and see how it's done, I think you'll remember it more. There's a lot of power in struggling with something like that as far as connecting it to your memory and internalizing it. If you struggle for 5 seconds and you're immediately bailed out of that, that's not going to stay in your memory as well as something that you spent a lot of time on. So here's how you do this problem. We're looking at a tangent line. So it says, what's the positive x value? We've got a tangent line to a curve, and this tangent line of this curve apparently crosses through the y-axis at the point 0, 2. So when you see tangent line, that tells you that we're going to use that, point slope formula. And m is the slope, x1 and y1 are the points, and then x and y are the actual variables. So when I looked at this problem, I said, well, I didn't say, but once I looked at the answer key, x, the variable is just going to be x. Y as the variable is going to be ln of 1 minus x. The slope is the derivative of the function, so that's 1 over 1 minus x times -1. You have to do the chain rule on that. And then x1 is the x-coordinate of the point, which is 0. And y1 is the y-coordinate of the point, which is 2. All right, so once you plug all of that in, you have the y value is ln of 1 minus x minus y1, which is 2, equals the slope, which is -1 over 1 minus x times x minus x1, which is 0. And all I did is I just cleaned it up a little bit. I left this side the same. And then here I went ahead and distributed this. So that gives me -x over 1 minus x, and then multiplying it by 0, so that's nothing. Now you could try to solve this by hand, but you don't need to because this is calculator active. So what I did is I graphed this side as y1, and I graphed that side as y2, and I knew that my x value was going to be some decimal between 0 and 1. So I went ahead and I made my window so that my x min and my x max were between -1 and 1, and then I just used the intersect option to find that x is 0.778. So kind of simple when you think of it this way. I never would have thought of that. But after I struggled with that problem so much to find an answer that was so simple, you know, just like figure out what y is, figure out what y1 is, plug it all in. Once I saw that, I don't think that's something that I'll likely forget very easily. So that's my 2 cents. All right, number 12. We're back to no calculator. So it says, for what value is the piecewise function continuous? Or for what value is it differentiable? For something to be differentiable, it has to be continuous, and the derivative has to be continuous. So this is f of x. We also want to know what f prime of x is. So this might be something, I remember thinking as I was looking through my notes for this section, like, oh, nothing in the chapter really covered piecewise functions. So this might be something that you should go back and kind of add to your notes for this packet, that you have to have a continuous function and a continuous derivative for it to be differentiable. So my derivative here is 2 times ax plus cos x, and the derivative of this one is just 2, and that's if x is less than or equal to pi, and this is if x is greater than pi. Okay. So what I did for the first one is I just took this function. I know it can equal pi here, so I evaluated it at pi. So a times pi squared plus sine of pi equals, and if you're doing this in a free response, you should not just plug in pi for this one. You should do the right-hand limit of pi. You should do the limit as x goes to pi plus, and then kind of plug it in that way. But since this is not a free response, I'm just going to go ahead and plug it directly in. So there's one equation I have. I can simplify this a little bit because I do know that sine of pi is 0. So a times pi squared is 2 pi minus c. No calculator use on that, so I'm just picturing my unit circle in my head. I'm going to do the same thing over here. So 2a times pi plus cos pi equals, there's no place to plug the pi in here, so it just equals 2. Cos of pi is -1. So that gives me 2a pi minus 1 equals 2. So in this equation, I can go ahead and solve for a. So I'm going to add 1 to the other side. I get 2 pi a equals 3. Divide by 2 pi. And I get a equals 3 over 2 pi. So now I can go ahead and take that a and plug it in over here. So 3 over 2 pi times pi squared equals 2 pi minus c. I can cancel out 1 pi with 1 pi, and that gives me 3 pi over 2 equals 2 pi minus c. So 2 pi minus what is what gives me 3 pi halves, and that means that my c must be pi halves, because 2 pi minus pi halves is what gives you 3 pi halves. So there's my answer right there, and that corresponds to D, it looks like. All right, tan inverse, they want you to find the derivative of that, so dy dx, if you guys remember, y prime is 1 over 1 plus x squared, and x just represents whatever is in here, and then it's the chain rule, right, so you have to use the derivative of the inside. So I've got 1 over 1 plus x squared plus 3x, x squared, so that's me plugging the inside into this x right here, so it's squared, times the derivative of the inside is 2x plus 3. And so that matches up with C. All right. They give you two functions, f of x and g of x. They're in the table. And then we have a new function, p of x. And they want us to find p prime of 2. So they want us to find the derivative of p. So I'm going to go ahead and do that first. I've got two things right here, so that's the chain rule. So, or not the chain rule, sorry, the product rule. So I've got the first times the derivative of the second plus the second times the derivative of the first minus, and then here I've got g of x. I'm going to do the derivative of the outside function first. So the derivative of the outside function is just the derivative of g. I keep the inside exactly the same. And then I multiply by the derivative of the inside. So we have product rule to start with, chain rule over here. It feels like kind of a complicated problem because the notation is a little bit different than what we're used to seeing. So you just have to think through the problem and make sure that you are using the definitions of things in your head. I might not have seen this before, but I can recognize the product rule and I can recognize the chain rule and I can figure out how to use them in this situation. So now I can go ahead and just think of evaluating this that I just got at 2. So I've got 2 times f prime of 2 plus f of 2 minus g prime of 3 times 2 is 6. 6 minus 2 is 4 times 3. All right, so this is 2 times f prime of 2 is 1 plus f of 2 is 5. G prime of 4 is -1 times 3. All right. So order of operations tells me that multiplication comes before addition and subtraction. So 2 times 1 is 2. -1 times 3 is -3. Minus minus makes a plus. So 2 plus 5 is 7, plus 3 is 10. All right. So we're hitting another related rates problem. It says when the height of the cylinder is 12 centimeters and the radius is 4 centimeters, the circumference of the cylinder is increasing. So we have a few things happening. I know the height of my cylinder. And then my radius is 4 centimeters. And I've got circumference. And I remember that circumference is 2 pi r. So I went ahead and wrote that. That's a formula. If you remember in related rates, there's typically some formula that's not necessarily calculus related. There's some formula that we've learned about in the past that they're going to use in the problem. So this one happens to be circumference, so 2 pi r. Circumference is increasing at a rate of pi fourths centimeters per minute. The height of the cylinder is increasing 4 times faster than the radius. So I can see that my CD, DC, DC, something about this is wrong. DC dt is pi fourths centimeters per minute. And then the height of the cylinder is increasing 4 times faster than the radius. So they don't give us any numbers there. They're not telling us the value of those two things. They're just saying, they're telling us the relationship. So I know that the height is changing 4 times faster than the radius. I'm going to take the radius and multiply it by 4, and that's what gives me the height, or the rate of increase of the height. Okay. Now they're saying how fast is the volume of the cylinder changing? So I don't remember the volume of a cylinder. I know that a cylinder looks like this, right? It's like a tube. That's a cylinder. So I know that the volume of anything that's consistent, right? Like it's not going out, it's like consistent going up. I know that volume is area of the base times the height, and I know that the area of this base is a circle. So my volume is going to be the area of the base, which is pi r squared, times the height. I will say I got this problem wrong several times before I got it right, because I was thinking 2 pi r times h, and it totally messed me up, and I had to do this problem for a really long time. So, but I will say I did get it without looking at the answer key. It just took me a while. So, so here's the two formulas that we're working with here. So what I realized was, if I go through this and I say how fast is the volume of the cylinder changing, then that means that dV dt is what I'm trying to find. So I went ahead and I said the derivative dV dt is, and I've got the product rule happening right here, right? I've got r times h, so, or pi r squared really. So I'm going to say the first times the derivative of the second, so that's 1 dh dt, plus the second times the derivative of the first, so that's 2 pi r dr dt. And so that gives me an idea of the different pieces of information I need to be able to finish this problem. I need to know what r is and what h is, and that's good because I've got them already. But I need to know a specific number for dh dt and a specific number for dr dt. And that's where I realized that this information is going to be important for me to figure that stuff out. So over here I was like, okay, I know what dc dt is, so let me go ahead and go through the process of using that information to find something else. So I took this formula right here and I said the derivative of c, dc dt, is 2 pi times dr dt. So that means that I can use this formula to solve for dr dt. So I've got pi fourths centimeters per minute equals 2 pi dr dt. So I'll divide by 2 pi, divide by 2 pi. So this gives me pi over 4 times 2 pi is 8 pi. So pi times 8 pi over 8 pi is dr dt, which is 1/8. So now I know my dr dt is 1/8. I know that dh dt, and my units here are centimeters per minute. Units are good. I know that my dh dt is 4 multiplied by that. So 4 multiplied by 1/8 is 4/8, and that's just 1/2. So now I have all the information I need. I have the r, I have the h, I have the dr dt, the dh dt. So dv dt is pi times 4 squared times dh dt is 1/2 plus h, which is 12, times 2 pi times r, which is 4, times dr dt, which is 1/8. Now, the reason that I'm not including units as I do this computation, if I was doing a free response, I would definitely include units so I could make sure that my units are accurate. The reason I'm not doing that is because all the units are the same in the answer choices, and so they are not testing me on that. All right, so here I've got pi, that's 16. 16 divided by 2 is 8. So I've got 8 pi. Plus 12 times 2 pi is 24 pi. 4 times 1/8 is 1/2. So I have 8 pi plus 12 pi, which is 20 pi. And that is the answer. All right, now time for our free response question. An isosceles triangle is inscribed in a circle as shown in the diagram. It continues to be inscribed as the semicircle changes size. The area of the semicircle, that's important. They're giving us, they're telling us what formula that is not calculus, what formula from our past that we can use, is increasing at the rate of 1 centimeter squared per second when the radius of the semicircle is 3 centimeters. My first thought when I read this was, oh my gosh, is there a special formula for an isosceles triangle? And I was like terrified. I was like, I don't remember that at all. The nice thing is, if you look at this triangle, we know from the past that the area of a triangle is 1/2 base times height. And if you look at this picture, this is a very nice problem because the base of the triangle is the diameter. And the height of the triangle, assuming, actually not, I guess this, yeah, this is isosceles. That's what makes it important, is that this length is the same as that length. So the nice thing about this is that this height right here is the radius of the circle. And that's why it was nice that they told you it was isosceles, is because they're telling you you can kind of split this in half and these two pictures are going to be the same because these two side lengths are the same. So that actually makes it very nice. So we have two formulas happening here. We have one that's the area of the triangle. So I'm going to write this up here, just as I'm not answering any questions yet, I'm just writing stuff down. So the area, and I'm going to go ahead and put the area of the triangle, or maybe I'll just put T. Area of the triangle is 1/2 times the base, and the base is two radiuses added together, r plus r, times the height, which is also the radius. So that means that the area of the triangle is radius squared. All right, so 1/2 base times height. I also know that the area of my semicircle is going to be 1/2 pi r squared, because it's half of a circle, and a circle is pi r squared. So that gives me the two big picture formulas that I'm going to be working with for this problem. All right, so now we have to look through and see specifically what is question. Well, actually, we have more information, sorry. The area of the semicircle. So dA s dt is increasing at a rate of 1 centimeters squared per second when the radius is 3 centimeters. Okay. So that's important. All right. So part A. How fast is the radius of the semicircle increasing when the radius is 3 centimeters? So they want dr dt. Include units in your answer. That means that as I do all these computations, I'm going to be very careful to use the units in my answer. Now notice they're asking how fast is the radius of the semicircle increasing when the radius is 3 centimeters. They're not saying anything about the triangle. They're asking about the semicircle. So for this problem, I'm going to be using this formula. So I'll go ahead and take the derivative, because it says the radius is increasing. So I'm going to say the derivative of the area is, and I'm going to take the derivative of this, 2 multiplied to the front. 2 times 1/2 is 1 pi r to the 1 power times dr dt. So the derivative of the area of a semicircle, that's 1 centimeter squared per second, equals 1 pi times 3 centimeters times dr dt. So I'm writing the units in the problem because it's going to help me get the units of my final answer. So now I can go ahead and divide the 3 pi over to the other side. So I'm going to divide by 3 pi centimeters, divide by 3 pi centimeters, and I get, see my centimeters cancel on top and bottom, I get 1 over 3 pi centimeters per second equals dr dt. All right, and they did say that you can use a calculator for this question. So if you want to write the decimal, you just have to be careful to only put 3 decimal places. That's 0.106 centimeters per second. So the points for this problem are given, 1 for finding dA dt, and then 1 for finding the final answer, and you could write the answer either way. They had both choices as good, valid answers. At the very end of the problem, they do say that there's 1 point allowed for the units for all 4 parts. So that means that we've just earned 2 points and then we're on our way to earning that point at the very end. Okay, so there's part A. Part B wants us to find how fast the perimeter of the semicircle. Now, I almost did this wrong. When I was looking at the perimeter of the semicircle, I was like, the perimeter of a circle is 2 pi r, right? That's circumference, and I divided it by 2, and I said the perimeter of my semicircle is just pi r, and I did the whole problem based off that. And I forgot that when you look at the picture, the perimeter is not just the circular outside, it's also this line straight across. And I had to go back and do the whole problem again. Thankfully, it was before I checked the answer key, so I would have gotten the points if I had taken the test, but you got to be careful. So I was getting cocky because I was like, oh, that's circumference, I know what that is, that's easy. So just be careful when you do these problems. So that's the circular outside part, and then plus the diameter, that straight part across the bottom. And I'm going to call this r plus r. So I'm going to call it 2r. So there's my perimeter. It says, how fast is the perimeter changing when the radius is 3 centimeters? So that means that I need the derivative of that. So dp dt is, I'm going to go ahead, I can do it separately. Pi times dr dt plus 2 times dr dt. And now the interesting thing about this is that you have to have the answer for A right to be able to do this question, because they need dr dt when the radius is 3 centimeters, and we just found that. That's 1 over 3 pi. So this is going to be pi times 1 over 3 pi plus 2 times 1 over 3 pi. Now, if you do not want to do this in exact form, you want to use decimals for this, that is totally fine. But this decimal would need to be stored in your calculator. You should not use the rounded decimal to plug into the middle of a problem. You can only round at the very end, so you would be using the exact form of this decimal, whatever 1 divided by 3 pi is. You should store that in your calculator, use that instead. So it's up to you if you choose to do that. So this is 1 over 3 plus 2 over 3 pi. Our units on this, dr dt is centimeters per second and centimeters per second, and so our answer is this, centimeters per second. And you can go ahead and plug that into your calculator to see what you get. And you end up getting 0.546 centimeters per second. And so this is 2 points again, 1 point for the answer, and both answers would be fine, and 1 point for your dp dt. All right, part C. Part C says, how fast is the area of the isosceles triangle increasing when the radius is 3 centimeters? Include units in your answer. So the area of the triangle, I'm just going to copy it down here, was r squared. So dA dt, the area of the triangle, is 2r times dr dt. And so the area of the triangle is 2 times 3 centimeters times 1 over 3 pi centimeters per second. And the 3 cancels. Gotta see where I wrote this down. So make sure I'm doing it right. So we get 2 over pi centimeters squared per second. And if you plug that into a calculator, you should get 0.637 centimeters squared per second. And so this problem is again worth 2 points, I believe, 1 point for dA dt, 1 point for the answer. So we just got both those points. All right, last part. D. I'm ashamed to say I got this one wrong. So when I was reading the question, it says, how fast is the shaded region increasing when the radius is 3 centimeters? I read the problem as, what is the shaded region? So be careful. You can, when you feel like you're getting confident in a problem, you can get cocky and make mistakes. So we have to figure out how to describe this shaded region. So if you look at the shaded region, it is half of a semicircle. So it is 1/4 of a whole circle. So the area of the shaded region is going to be 1/4 of the circle minus, we have got to minus off this triangle right here, and the area of this triangle right here is 1/2 of the base, which is the radius, times the height, which is also the radius. So minus 1/2 of the base, which is the radius, times the height, which is the radius. Okay, so that gives us 1/4 pi r squared minus 1/2 r squared. So, that's not dAdt, that's just A. Okay, so now we can go ahead and find the derivative of that to see how it's increasing. So dAdt is 2/4, which is 1/2, 1/2 pi r dr dt minus 1 r dr dt. So my r is 3 centimeters, my dr dt is 1/3 pi centimeters per second, minus 1 times 3 centimeters times 1/3 pi centimeters per second. Again, remember, if you had stored numbers here, you could have been using those stored numbers and typing it in your calculator and saving some time. So pi and the pi cancels, 3 and the 3 cancels. So I've got 1/2 centimeters squared. Well, I guess I can use the units at the very end. So I've got 1/2 minus 3 and 3 cancel. So I've got minus 1/pi, and then the units on this is centimeters squared per second. And I can go ahead and plug that into my calculator, and I get 0.182 centimeters squared per second. So again, this is worth 2 points, 1 point for the dAdt in here, and then 1 point for the final answer. And then our last point, our 9th point, is for having correct units throughout the problem, which we did because we used them in our formulas.